Hi there, and welcome to this pre-induction screencast developed by the Learner Development Team at Manchester Metropolitan University. My name is Victoria Herod, and I'm an Academic and Study Skills tutor at the university. I'm one of a team that offer academic support to all students at any stage of their course. Today we will be considering the following question. What statistics may I encounter at university? Aiming to give you a head start to your studies in September. Let's begin. In today's session, I'll be aiming to expose you to a variety of statistical terminology that you may hear being referenced when you start your studies. For each of these, I'll be providing a brief introduction, including signposts to where you can find more detail should you need or desire to. Let's start. When I took up the role of numeracy specialist within the academic support team, I was fielding a lot of questions from students. However, they all centred around the same common queries. The main support was required around statistical testing, variable types, p-values, representing data, and the normal distribution. Due to this, I've compiled the following list of big hitters, the topics within statistics that seem to always be referenced regardless of what programme you're enrolled onto. This is by no means an exhaustive list of everything you may come across relating to maths and stats while at university, but you may hear these terms thrown around. This session is intended to give you enough of a background to these topics to give you sufficient knowledge base to get you through until you can visit the library or study skills for further help, that is. I've separated the topics into 4 main themes. If your maths experience ended with GCSE maths, then you'll be familiar with the topics highlighted in green. If you studied A-level maths, then most of the topics listed will have been covered in the syllabus, regardless of exam board. And if you have a background in psychology, then the terms highlighted in blue will be familiar to you. Let's delve into these a little further with a nutshell overview of each. Further reading will be linked and suggested as a follow-up activity. Within the describing data strand, I have highlighted the following topics: levels of measure, measures of central tendency, and measures of spread. Let's look at the first in a bit more detail. Levels of measure. You may have heard the terms quantitative and qualitative data before, quant being number-based data and qual being word-based data. In higher education, these are further divided. Qualitative data is categorical, being broken down into either nominal data or ordinal data based upon whether there is an implied ranking or not within the categories. For example, hair colour and eye colour is nominal, as there is no hierarchy between the categories. Level of education and satisfaction, however, do have an implied ranking within them, so they are ordinal data. Quantitative data is known as continuous or scale data in higher education. Measures of central tendency. You will have seen these before, but quite possibly not known the overarching term for them. This is the branch that contains the mode, median, and mean, all ways of describing a data set, dependent on the measure type. The mode being the most common, the median being the middle value when ordered, and the mean representing the fair share amongst values. Measures of spread. The range being the difference between the largest value and the smallest value, and interquartile range, the difference between the first quartile and third quartile when the data is split into 4 equal subsets, is covered at GCSE, but that may have been some time ago for a few of us. One thing you may not have seen before, but you may encounter a lot in higher education, is the measure of standard deviation and variance. This is a measure of how far each data point is from the mean. The smaller the standard deviation, the more tightly packed around the mean the data is, and thus can be considered a more consistent data set. Within the representing data strand, I have highlighted the following graphs and charts: histograms, box plots, and stem and leaf diagrams. Let's look at the first in a bit more detail. Histograms. The purpose of a histogram is to graphically summarise the distribution of a single dataset. It allows the reader to easily interpret spread and skewness of the dataset and assess for the presence of any outliers. Box plots. A box plot displays the 5-number summary of a set of data, thus allowing for easy comparison between multiple datasets. The 5-number summary is the minimum value, the first quartile, median, third quartile, and the maximum value of the dataset. Stem and leaf diagrams. A stem and leaf diagram shows numbers in a table format. It's more suitable to smaller datasets. It can be a useful way to organise data to find the median, mode and range of a set, and provides the reader with a visual representation of the spread of data. Within the distribution strand, I have highlighted the following topics: normal distribution and confidence intervals. Let's look at the first in a bit more detail. Normal distribution. You may hear the normal distribution being referred to as a bell curve based upon the shape it creates, or the Gaussian distribution, named after the mathematician who discovered it. It is defined by 2 parameters, the mean and the standard deviation. On this picture, you can see that the green distribution has a lower mean value than the others, as it appears lower down on the x-axis. The standard deviation is interpreted by looking at how spread out or wide the distributions are. The yellow distribution has the largest standard deviation of them all, as it is the widest distribution. Normal distributions give us a few probabilities with where the data will lie within it, and thus allow statistical testing to see whether assumptions about a sample are reasonable or not. Most importantly, approximately 95% of the area of a normal distribution is within 2 standard deviations of the mean. That leads us nicely on to confidence intervals. Confidence intervals. We reported before that 95% of the area, and thus the data, lies within approximately 2 standard deviations of the mean. In fact, it is exactly between 1.96 standard deviations. As the majority of quantitative analysis is undertaken to make generalisations about a population based on a sufficient sample, it is necessary to report these findings within a confidence interval on occasions. The confidence interval is a range of values that's likely to include a population value with a certain degree of confidence. For example, the probability of the population mean value being between 1.96 and negative 1.96 standard deviations from the sample mean is 95%, as illustrated by the diagram. Accordingly, there is a 5% chance that the population mean lies outside of the upper and lower confidence interval, as illustrated here by the 2.5% of outliers on either side of the 1.96 scores. Within the statistical significance strand, I have highlighted the following topics: hypothesis testing, error types, and p-values. Let's look at the first in a bit more detail. Hypothesis testing. Hypothesis testing is used to assess the plausibility of a hypothesis by using sample data. In order to do this, you would start by devising the null hypothesis, referred to as H0. The null hypothesis is a statement that's assumed to be true unless there's strong evidence against it. You would then devise the alternative hypothesis, referred to as H1. The alternative hypothesis is a statement that is accepted if the null hypothesis is rejected. You also need to specify the level of significance. Commonly, 5% is acceptable for most research. This is explained a little bit more on the next slide. Error types. There are 4 possible outcomes when conducting hypothesis testing. 2 of them would be the correct conclusions, either not rejecting H0 when it's true and rejecting H0 when it's false. Obviously, either of these are desirable outcomes. However, that means that there are two outcomes that could result in an error being made. We have not rejecting H0 when it's false, resulting in a type 2 error, but more disastrously would be rejecting H0 when it's true, resulting in a type 1 error. For an equivalent analogy, this would be like letting a guilty party go free in a court of law, an obvious miscarriage of justice. When conducting hypothesis testing, we set a maximum percentage of type 1 errors permitted, typically 5% or 0.05 as a decimal as referred to before. This is known as the significance level. P-values. When using a statistical package, such as SPSS, to conduct data analysis, a significance value will be outputted alongside the result. This is sometimes referred to as the p-value. A p-value helps you determine the significance of your results in relation to the null hypothesis. A p-value less than 0.05 is statistically significant. It indicates strong evidence against the null hypothesis, as there is less than a 5% probability that the null is correct. Therefore, we reject the null hypothesis and accept the alternative hypothesis. Beware, this does not mean that there is a 95% probability that the research hypothesis is true, however. A p-value higher than 0.05 is not statistically significant and indicates strong evidence for the null hypothesis. This means we retain the null hypothesis and reject the alternative hypothesis. Time for a quick quiz. How much do you think you have remembered from the brief nutshell introductions then? If you'd like to test yourself, pause the video and try the questions on screen. When you're ready, click play and the answers will be revealed. Here are the answers to the short quiz. How did you do? Don't worry too much if you didn't get them all correct. What is more important right now is that you know where you can go to answer these questions or any others should you need to in the future. Here are some links to external websites should you want further information on any of the topics discussed today. Support from the Learner Development Team is also available to all students while studying, regardless of level or programme. The best way to contact us is on the email address studyskills@mmu.ac.uk. I hope you have found this video helpful and good luck in your future studies with us at Manchester Metropolitan University.